Chapter 4, Planning in a Problem-Based Classroom. Those who fail to plan to fail. No plan means you don't have a plan to help your students succeed. A three-phase structure for lessons. You have the before, where you're getting ready. During, that's the students' work, you're doing it. And after, that's the class discussion and learning from their ways. The before phase, the first 5 to 10 minutes, you're activating the students' prior knowledge. What do they already know? Is it vocabulary? And what tools would they think they would use to solve these focused tasks? Also, try to connect it to life experiences. Be sure the task is understood. Analyze problems and anticipate students' approaches. Every student does the problem differently. Question, what are we trying to figure out? Do we have enough information? Do we already know how to get started? Most difficult facts can each be connected or related to facts already learned. Foundational facts are known facts. Establish clear expectations, how you want students to work, what products they are to prepare for discussion. It's always a good idea for students to have the opportunity to discuss their ideas with classmates prior to sharing their thoughts. Also, so we know that every student's working, it's a great idea for your lesson to start with think, write, pair, and share. So think what you're going to do, write it down as an individual, and then share it with your partner. Because teaching through problem solving focuses on processes, strategies, and solutions, it's important to model and explain the final. Let's go. Allow and encourage students to embrace the struggle. Don't be tempted to rescue students who are feeling frustrated and uncertain in the during phase. They will learn more if you provide support without just showing or telling them the answer. Notice students' mathematical thinking. Take time to find out what they are thinking and ideas they are using. This is the time for observing, listening, and interacting with students. Professional notice means that you are trying to understand the student's approach and learn from them. Provide support. Think of ways to support without taking away their responsibility for designing and solving the problem. Ask students what have they tried and possibly suggest general strategies. Provide worthwhile extensions. Be prepared for students who finish quickly and how you can extend their thinking without it seeming like extra work. Do you think there are other solutions? Are any of the other solutions different or more interesting than yours? Which of the shapes with a perimeter of 18 has the largest area? These are some possible questions that can allow students to extend their work. After phase, promote a mathematical community of learners working together and having productive discussions. Students feel comfortable taking risks and sharing ideas. Students respect one another's ideas, even if they disagree. Listen actively without evaluation and use this as a second chance to find out how students are thinking. The wait time. The goal here is to notice students' mathematical thinking and how they do work. Summarize the main ideas and make connections or lay groundwork for future problems. List different strategies on the board, share verbally how they did it or their work, their answers. Oral summaries with individual writing summaries, exit slips. Ask students to write a newspaper headline to describe the day's activity or a brief column to summarize the day. Steps, lesson planning process, content and discussion, determine the goals, student needs, select and design and adapt worthwhile tasks, design lessons, the lesson before, during, after, and then reflect at the end. Step 1, know your focused mathematical learning goals. What is my thoughts my students should be able to do when the lesson is over? What content is important? What mathematical practice or processes will be developed? What are my objectives for the lesson? 2, consider your students' needs? What do my students already know? What content or context might be engaged to this range of learners? What misconceptions might be needed to address? What visuals or models will support the learning? What vocabulary support might be needed? Select a task and use 4-step guide for activity evaluation and selection. In Chapter 3, does the task address the content goals and my students' needs? Does the task have potential to engage students in mathematical practices? Will the task require students to apply problem-solving strategies? It is absolutely essential that you do the task yourself. It is only when you explore the task that you can identify the possible challenges and anticipate students' approaches and determine strategies you want to be highlighted. Design the lesson assessment. Make sure your assessments allow students to demonstrate their understanding of the content goals. Formative assessment allows you to gather information that you can be used to adjusting the direction of the lesson mainstream or making changes for the next day, as well as informing questions you pose in the discussion of the task and for after the phase. Summative assessments capture whether students have learned the objectives you have listed for the lesson. After class discussion, promote the community of learners listen actively without evaluation, summarize the main ideas, and make connections. How will you organize the discussion? What questions will you ask? How will you involve all students? What evidence are you seeking that will tell you how students understood or not understood the problem? A worthwhile problem can take 15 to 20 minutes to discuss. Refine. Make sure all 3 parts before, during, after are aligned and balanced to your learning goals. Review to see if opportunities for students to engage in mathematical practices and/or problem strategy are evident. High-level questions are based on the learning goals. Be prepared with key essential questions that will extend, analyze, compare, and generalize and synthesize how students learn, how they get the right answer, do they work best with partners, and leverage practices. High leverage routines are routines that practice and design around developing students, numeracy, engaging students in actively doing mathematics. The 3-act math task. First, Act 1, you share a visual context video to pique their interest. Act 2, students identify the variables needed to solve the problem and define the solution path. Act 3, include with the reveal through digital media and sharing out and discussing of the mathematical word-based problem. Number talks. Present a problem. Engage the students about how it might be solved, not giving them the answer. Teacher facilitates this discussion with questions about students' thinking and strategies. Come up with these questions before the lesson you give and point out of the number talks in the talk. It should only take about 5 to 15 minutes. Worked examples is an already solved task that students analyze. Students look for correct or partial solutions as well as incorrect solutions, brings light to alternative solution strategies, common errors and misconceptions. Can be used as a number talk or say a full lesson or as homework. To design an effective work example, consider analyzing the topic you are teaching, anticipate important strategies and/or common misconceptions, write or find a problem that highlights the strategy, complete the problem in a way that brings attention to the strategy, and construct questions that require students to explain misconception errors and/or concept. Differentiating instruction. A lesson plan includes strategies to support the range of different academic backgrounds found in a classroom. Consider what can be differentiated. Content, what you want each student to know. The process, how will you engage them in thinking. Product, what they will show and write or tell to demonstrate. And consider the physical learning environment, the seating, grouping, small group, large group, on their own. Remember, content can be differentiated in many ways. Resources, manipulatives, vocabulary, examples, non-examples. Questions. Broad-based questions that invite meaningful responses from all students from all developing levels. Example, one number is about half of a number. Their product is close to 100. What might the numbers be? Some background information. Product, which means answer to a multiplication. Is equal to. One number is about half. So if you start with 5 and 10, that's 50. Well, that didn't work. Let's try 7 and 14, 98. Well, it's about or close to 100. So I would say my numbers are 7 and 14 because 7 is half of 14. Here lessons, a set of similar problems focus on the same mathematical goal with adaptations to make the range of learners. The degree of assistance, provide examples. How structured is the test for special needs? Benefit from highly structured, from gifted to low structured. The complexity of the task given. Task more concrete or more abstract or more difficult problems or applications. The complexity of the process, how quickly the lesson is, how many instructions you're giving at one time, and how many higher order thinking questions. In this problem, for the degree of assistance, I would show them a few examples and also let them work with a partner. 2, how structured is the task? What adaptations you might make for gifted students. For advanced students, maybe I had I take away 3 ounces and have a blank there and have a total of this many bags and see how many ounces each bag holds. For our IEP student, I might make the numbers smaller and give them some further instructions. I would have students either model on graph paper or use chips. The time frame depends on my students. Parallel tasks involve choice. Choice helps motivate students to become more self-directed learners. Choose scientific notation, which select one of the numbers below and represent it at least 4 different ways. Grade 2. We have one student with 12, 60, 121 marbles, and another student 5, 15, 46. How many marbles does this person have now? What student's choice provides useful formative assessment? Flexible grouping allows students collaborations on tasks, provides support in challenges, increases the chance to communicate about mathematics. Size and makeup of students groups vary in purpose and strategic manner. Key to successful grouping is individual accountability. Each person responsible for content, process, and product. Establish team building for shared responsibility. All members will participate. Provide support for parents to understand the mathematical goals in the 21st century. Family Math Nights showcase the mathematical program, provide opportunities for parents to engage in doing what their students are doing, their children are doing. Talk about the learning through inquiries with their teachers and students and their parents. Describe the role the teacher plays in the query-based classroom. Forming questions, helping students generate questions, helping students answer questions, documenting what students answered. Justify the use of cooperative group, advocate for the use of technology. It's okay to use the calculator in your classroom. Provide support for how parents can help their children problem solve, address concerns about teaching parents how to help their children have been found to make a difference in supporting student achievement. Mimic the 3-phase lesson model to make sure students understand the homework before, during, and after. Distribute content approach means that the students can practice content as reinforcements or upcoming content or groundwork. Ask before telling approach. Provide good question prompts for parents to use as a guide for connecting school and home. Have parents, families make a math promise. They explicitly agree to do math together to get to know their reasoning, play games, notice mathematics in their daily lives. Share honor different strategies, communicate with positive notes or phone calls, Host informal gatherings to discuss mathematics. Incorporate homework that involves family. Put homework on your webpage.